Okay, let us see here one more problem. The problem is a ball is thrown with a velocity u making an angle theta with the horizontal. Its velocity vector or the velocity vector is normal. This is normal here. The velocity vector is normal to the initial velocity. Normal is nothing but perpendicular vector after a time interval of, okay, let us see here. A ball is thrown with a velocity u. So let us see here. This is the diagram. Now here a ball is thrown like this. It is moving in like as a parabola shape. This is the initial velocity. This is maximum. Now a ball is thrown with the initial velocity u, making an angle theta with the horizontal. Its velocity vector is normal to the initial velocity after a time interval. For example, this is I am going to extend it. This one goes to like this. This one, there is a point here. This is the velocity. Let us assume at this point. At this point, we are going to observe this velocity. Here, these two are making an angle 90 at this point. So, at what time interval? Not only here, maybe here, whatever it is. At this point, we are going to extend like this. So, at any point, the initial velocity vector and final vector making an angle 90. Normal means 90. So, these two are normal to each other like this, normal angle 90 like this. Okay, at what time? So, they given here according to problem, initial velocity we need to calculate. Here, we need to find the initial velocity in this condition. So u is equals to, actually this can be resolved in two components, u cos theta and u sin theta. U cos theta and u sin theta. Now this can be written as u cos theta I cap plus u sin theta j cap. This is the initial velocity. This one is called as initial velocity. After some time we are going to get a final velocity. Final velocity formula Vx I cap plus Vy j cap. This is the point. So at any interval time, so Vx is always constant. Now I am going to calculate here. So Vx is always constant. That is Vx is always constant. Horizontal component is remains constant. That is u cos theta only. U cos theta. But vertical component after time. So ui minus gt. Here ui is nothing but u sin theta minus gt. This is the vertical component of velocity after time t. So now I am going to substitute in this equation. Final velocity v is equals to u cos theta I cap minus plus vy is nothing but here u sin theta minus gt j cap. This is j cap. So this is the final velocity, but they given here initial velocity u and v are perpendicular to each other. So now that means u dot v is equals to 0. Velocities. So now what is the initial velocity here? This is the initial velocity. So now here u cos theta I cap plus u sin theta j cap dot u cos theta I cap plus u sin theta minus gt j cap, that is equals to 0. So this is a dot product. Dot product means I to I, j to j. So here I to I means this is u cos theta into u cos theta whole square. That is equals the again plus u sin theta into this point. So now u sin theta into u sin theta minus gt, that is equals to 0. That is equals to 0. So now in this condition I am going to consider here u sin theta is going to write u square cos square theta plus, after multiplication, this is u square sin square theta minus u sin theta gt, that is equals to 0. Here we are going to take common factor e square. If you take common factor e square, this is cos square theta plus sin square theta minus, this minus goes to that side, u sin theta gt. This one we are going to write here cos theta into cos theta, cos square theta plus sin square theta is equals to 1. So now here u square into 1, that is equals to u sin theta g theta sin theta gt. Now here 1u gets cancelled. Now t is equals to, this is u by sin theta into g, that means g sin theta. So now time t is equals to u by g sin theta, So this is the, after time, the initial velocity and final velocities are makes normal to each other. Normal means perpendicular to each other. So this is the problem. Thank you. Now that means answer means t is equals to u by g sin theta. The answer is this point. Thank you.